Assalamu alaikum. My name is Iman Jassim. This scientific paper deals with improved face detection method based on optimization algorithm. Introduction. Biometric is the science of analyzing physical or behavioral characteristics specific to each individual to authentication their identity. Recently, biometric features have replaced traditional passwords which can be lost or stolen. It is harder to recognize a face when there are changes in posture, facial expression, and lighting in the facial image. The face detection works that rely on the transform domain, including DCT and wavelet transform. In DCT, the features lie in the white pixels, which are at the low frequency of the image. In a wavelet, the feature lie in the edge, but it works in only three directions: horizontal, vertical, and diagonal. Therefore, in this paper, a new face recognition technique based on curved transform for feature extraction and path optimization for feature selection is proposed. For classification was used the AdaPost and random forest classifier. Problem statement. In the DCT, a pixel's DCT coefficient increases with pixel whiteness and decreases with pixel blackness. The DCT value to the lower frequency constitutes a crucial component of the original image. The solution is either discrete wavelet transform or a curved transform, which deal with high frequency where the edge lie. The discrete wavelet transform is a workable method for photo denoising that keeps the essential facial traits. The horizontal, vertical, and diagonal lines only in edge one represent a distant feature from the original image. The curved transform is a multi-direction and multi-scale transform that represents edge and other single along the curve more precisely and previous multi-scale transforms. The edge representation in curved and wavelet transform is displayed in figure below. In the fine scale, a greater number of large coefficients can represent the wavelet edge in the left, and a small number can represent the curved edge in the right. Proposed method. The proposed method consists of four steps: pre-processing, feature extraction using discrete curved transform, feature selection by path optimization, and classification in the final stage. As shown in the algorithm below and block diagram, the algorithm input yield dataset, output confusion matrix. For all image in the yield dataset applied, read the face image and normalization on the face image and apply the Gaussian filter to the face image. Finally, resize image. This apply in pre-processing stage. And feature factor by a discrete curved transform. This is apply in feature extraction stage. And select factor by path algorithm. This is applied in feature selection stage. And finally, pass the vector of feature into random forest and adobist for training and testing. In this block diagram, dataset input to pre-processing is applied, normalization, Gaussian filter, and resize, and feature extraction by curve transform, then feature selection by path optimization. Finally, classification by random forest and adobist. Step 1. Pre-processing. The first stage is pre-processing, which contains several important operations to improve the input image. First is normalization image and Gaussian filter, and finally resize image step. In the normalization image step, normalization of a gray image is crucial in image enhancement by removing noise and adjusting the range of pixel intensity value. Then, Gaussian filter step. A Gaussian filter was applied because it is the most effective on facial image to reduce noise. The standard deviation of Gaussian is 0.2, which determines the amount of smoothing applied to the image. Finally, resize image step. The process of change the size of image in the database to represent all images in the same size and improving the performance of the model in the next step. The image will resize from range 320 by 243 to 128 by 92 in order to make them compatible with the suggested facial recognition technique. Step 2. Feature extraction. Several image processing issues have been resolved with the extensive use of the discrete curve transform by equation below this, by applied fast Fourier transform on the image and applied high pass filter. We used to determine the high frequency factor to extract the most important facial feature. And finally, applied inverse fast Fourier transform. Step 3. Feature selection. The path algorithm was used in selecting the attribute. The path approach offers a helpful answer for face recognition. By this equation can be represent the path algorithm mathematically, where the velocity is update and position and frequency, where G-best is represent optimal solution and LP represent random number from uniform distribution and 1 to 0. Step 4. Classification. The classifiers we used are adaptive boosting and random forest. The basic idea of adaptive boosting is the same training set of data is used to train a large number of weak classifiers, which then combine to form a stronger classifiers. As for random forest, combine the result of many decision trees to greater prediction. The majority vote is the project value for classification, while the average is the predicted value for regression. A machine learning model requires 70% of the total data to training and 30% of the test set. Experiment result. The suggested technique is implemented in MATLAB 2023 on ASUS laptop with Core i7 CPU running at 1.5 GHz and Microsoft Windows 11 with 16 GB of memory. Yellowface database is used because the most well known. There are 165 gray images from 15 people in the Yale database. Age figure is have 11 different lighting and experimentation, such as normal, heavy, side, left light, right light, center light, with and without classes and other. Evaluation measure. Depending on the four elements in the confusion matrix, Fn, false negative, false position, true negative, true position, these four elements result in the following measurement: present, resale, accuracy, F1 score, and error rate. Evaluation result. The table below displays the evaluation measure of the detection of two classification approach, one feature selection, one feature extraction. In proposed one, curvelet transform with but with adapted. In accuracy 97, present 97, resale 98, F1 score 98, so error rate is 3. In proposed 2, curvelet transform and but with random forest. In age evaluation measure is 100, so error rate is 0. Comparison. We will contrast the recommended technique with many strategies using different data sets. Show that our proposed is the better than other because it is achieve recognition accuracy of up to 100%. Conclusion. In our article, we have divided the proposal into four sections: image processing, and then feature factor represent the feature extraction from facial photo are extracted by curvelet transform. Then use the optimization technique to identify the feature factor by BAT algorithm. Lastly, using two classifiers, Adobe Post and Random Forest, for facial recognition. In age measure, the highest for the suggested curvelet transform, but with random forest, which scored 100%. The lowest accuracy, present, resale, and F1 score were optimized by the suggested curvelet transform, but with a double, which was 96, 97, 98, 98. In subsequent research, we will use the deep learning technique such as ANN after expanding the sample size in the dataset. In the end, thank you for your listening. Goodbye.